Okay, I feel like making a video about a couple of interesting sections of this book right here called Our Universe. It has a cool futuristic spaceship looking like thing on the cover. I've had this since I was very young, and I just wanted to point out a couple of the interesting sections in here regarding the flat Earth concept, because it seems like a lot of people who are really who really believe in the flat Earth idea, or I guess I'm not arguing either way, but I wanted to point out the stories that were in this book that I remember reading when I was like 3 years old, and this is the first one. It says, sailors in ancient Greece approaching distant islands first saw that the highest point of the land. As they drew closer, the islands seemed to rise up from the sea. So it made them believe that the earth was round. So they could, so as they approached land from distant parts of the ocean, people would more than likely be up at the top of their sails, up there at the lookout point, trying to look for the land, because that's how they would know if they were finally getting close to where they were going or not. And when the guy sights land from way up there, they would see the tips of the land first in ancient Greece. I'm not sure if I don't think they had the telescope yet, or the periscope, or any of those eyeglasses yet back in ancient Greece. So this was all by sight. So there's one actual realistic experiment that can be performed very simply, just by going out into the ocean and watching what happens to the top of the land, the top of the mountains from the land as you go away from the coast or whatever. That could be performed very easily, having to get on a plane or anything like that. And here's another one that somebody did in Egypt. Not real ancient Egypt, but 230 BCE. And this person, this Greek scholar living in Egypt, knew that in Syene, or Cyan, or whatever that place is in Egypt there, he knew that on every June 21st of the year, that the sun would shine directly straight down a well, and there was no shadows. The sun was going straight down a well whenever he knew this on every same day of the year, June 21st. And so on that same day, probably on a different year, he went 800 kilometers to the north to Alexandria, or Aswan as we know it today, and he measured that the shadow of a pole that he erected was 1/50th of a circle, and he multiplied 800 kilometers by 50 and got an estimated circumference for the Earth at 40,000 kilometers. And this is another simple experiment that can be done by anybody. And it only works if you go directly north or directly south. The angle of the sun won't change if you go west, east or west, but if you go north or south, and you measure the angles, or not the angle, where you measure the size of the shadow, and there should be a measurement difference in the size of the shadow depending on how far north or how far south you travel. But you have to do it on the same day of the year, and it has to be directly north or directly south from two different parts on the globe to see the shadow either increase or decrease in its length, and that'll tell you how round or how big the Earth's circumference is. Another real observation experiment that anybody can do to prove that Earth is not flat. But I'm not going to join this argument. I believe what I believe in, and I don't want to argue about it. I'm just going to say I believe in what I believe in, and I believe that the Earth is not flat. But to each their own. There is another argument about somebody performing a experiment similar to this one. The sailors would approach land, they'd see the top of the land. Somebody put a boat into a creek that he would push or have go continuously traveling away from him, and he had a telescope and he wanted to point it at and see if the boat would go down over an edge of some sort, and he said that it went a certain distance and it didn't. But I doubt that he went 800 kilometers like this person did. It's just, this is more factual and it has mathematical data to it, so it's kind of hard to argue against an experiment that you can perform that has actual measurements and data that you can prove that your experiment has been taking place and performed mathematically as well. So it's pretty hard to argue that, but everybody has the right to believe in whatever they want to believe in.